Welcome to this channel, Math Prime Board. I will enjoin you to like and subscribe to this channel so that whenever we post math content like this, you will be the first to see it. We're going to be diving very deep into topics in maths here. We have a problem before us today. How do we solve this problem? This is an exponential equation. We have 3 raised to the power of 2x plus 5 equal to 3 raised to the power of x plus 2, then plus 2. How do we solve a problem like this? I need us to know, recall the law of indices. A raised to the power n plus b is the same as a raised to the power of n times a raised to the power of b. I'm going to apply that law here. So, a raised to the power of 2x plus 5 can be written as 3 raised to the power of 2 times 3 raised to the power of 5. Then, the power of x plus 2 can be written as 3 raised to the power of x times 3 raised to the power of 2, then plus 2. Now, I want to recall another law of indices. While we are applying this law, on this side, we have 3 raised to the power of x. Here, we have 3 raised to the power of 2x. I want to rearrange the parts in such a way that I will have 3 raised to the power of x on the right-hand side. A raised to the power of n, everything raised to the power of b can be written as a raised to the power of b, everything raised to the power of n, because multiplication is commutative. So let's rearrange this in that form. I have 3 raised to the power of x, everything raised to the power of 2 times 3 raised to the power of 5 is equal to 3 raised to the power of x times 3 raised to the power of 2 plus 2. Now I have 3 raised to the power of x on both sides. So let m be equal to 3 raised to the power of x. So that on my right and left-hand side, I have m 3 raised by x, 2 outside, raised to the power of 2 times 3 raised to the power of 5 is 243. To give us m times 3 raised by 2 is 9, right? Is 9, then plus 2. So we have 243 m squared to give us 9m plus 2. Now, we move everything on my left-hand side to the right-hand side so that the equation will be equal to 0. There is an invisible positive sign here. When it crosses, it becomes negative. So we have 243m squared minus 9m. And when 2 crosses to this side, it also becomes the plus becomes minus. So minus 2, everything will now be equal to what? 0. Why? I moved everything in my right hand side to my left hand side. Now, this is a quadratic equation. You can solve this equation using the formula method, but I'm going to use factorization method. I'm going to use factorization method. The coefficient of m squared is 243, and the constant is minus 2. So 243 times minus 2 is minus 486. And the coefficient of m is minus 9. The fact of this will be two numbers whose product is 486, and the sum is minus 9. Now I'm going to be thinking two numbers that will multiply each other to 486. 1 times 486 is 486. 2 times 486 times 243 is 486. If I divide 243 by 3, I have 1. Multiply this by 3, I have 6. So 6 times 1 is 6 times 81 is 486. Now, I divide this by 3, I will have 27. Multiply this by 3, I have 18. 18 times 27 is 486. But this is interesting. You know, we add or subtract, we have to get minus 9. In this case, if I do 18 minus 27, 18 minus 27, I get minus 9. So these are the factors we are going to be using. Those are the factors we are going to be using. So we have 243m squared. 243m squared minus, I can pick any of the factors, but I'm picking minus 27. Minus 27 and 10. 10m minus 2 is equal to 0. Now, what number holds the highest common factor of 243 and 87 is 27. The highest common factor of m squared and m is 7 can go in 243 9 times. M squared divided by m is m minus 27m is 27 1. Then plus what number goes in both? The highest common factor 18 minus 2 is 2. It's 2. So 2 9m minus 1 is equal to 0. It's equal to 0. So let's go to another page to continue this problem. You know, I got 27 into 9 minus 1, 27 into 9 minus 1, then plus 2 into 27 plus 2 into, plus 2 plus 2 plus 2 into 9n minus 1 to be equal to what? 0. So that 27 plus 2 and 9n minus 1 is equal to 0. So how do we solve this? 7n plus 2 is equal to 0, or 9n minus 1 is equal to 0. 9n minus 1 is equal to 0. Now, 27m is equal to negative 2, so that m is equal to negative 2 over 27, or 9m minus 1 is equal to 0. So 9m is equal to 1, and m is equal to 1 over 9. I want us to know, look here, we said let m be equal to 3 raised to the power of x. So m is equal to 3 raised to the power of x. 3 raised to the power of x. Now, m is minus 2 over 27. There is no way we can take this to a number in the power of 3. The power in base 3. So we ignore this answer. Let's check this. Yes, we can take this to a power in base 3. So that we say 3 raised to the power of x is equal to 1 over 9. There is a law of indices that says 1 over n is equal to n raised to the power of minus 1. So 3 raised to the power of x is equal to 9 raised to the power of minus 1. I can take 9 to a number in base 3, power in base 3, sorry. So 3 raised to the power of x, 9 is equal to 3 raised to the power 2. 3 raised to the power of 2 into minus 1. To minus 1. So 3 raised to the power of x is equal to 3 raised to the power. Remember, 2 times minus 1 is minus 2. So it's equal to 3 raised to the power minus 2. Now the bases are the same, therefore the powers are the same. X is equal to minus 2. Thank you. See you next time.